A certain radioactive isotope is a byproduct of some nuclear reactors. Due to an explosion, a nuclear reactor experiences a massive leak of its radioactive isotope. Fortunately, the isotope has a very short half-life of 6 days. Estimate the percentage of the original amount of the isotope released by the explosion that remains 5 days after the explosion. So we're assuming here that we're dealing with another exponential growth and decay model. So we're following this model, A equals A naught e to the kt, where A naught is the initial amount, K is the growth or decay rate, and in this example, our radioactive isotope has a half-life of 6 days, meaning that it is decaying, and so that means our example will have a decay rate, and the value of K will end up being negative once we calculate it. Then we have T, which stands for time, and the value of A is the amount after time. So with this piece of information here, given that the half-life is 6 days, is enough information that I'm going to be able to calculate the decay rate for this model, for this radioactive isotope. So what that tells me is that if there is a half-life of 6 days, that tells me that the amount of that isotope will become half of whatever it started with, hence the word half-life, half of what it started with after 6 days. So our amount after time will be half of our starting amount, our initial amount, at a time of 6 days. So this is going to give me values to substitute into the exponential model. We have A equals A naught e to the kt. In for A, I'm going to substitute 1/2 A naught, because we're going to go to half of what we started with. We'll leave that A naught alone, and we're going to substitute in for time the 6 days, which is the half-life. So we're going to be able to solve this exponential equation by isolating the exponential portion. We would divide both sides by A naught. That cancels out the A naught on both sides. So I have 1/2 equals e to the 6k. I'm going to solve this exponential equations. We have 3 methods that we typically use. Relating the bases, which we can't do in this example. Converting to a log or taking the log of both sides. I'm going to take the log of both sides. I do the natural log on the left and the natural log on the right. Now that we've introduced the logs, I can use the power rule for logarithms. And the power rule for logarithms allows you to take this exponent and make it the coefficient of the log. We have 6k natural log of e equals natural log of 1/2. Natural log of e is 1, so that gives me 6k equals natural log of 1/2. And then I can divide both sides by 6. So we have k equals natural log of 1/2 over 6. I'm going to type this into my calculator. Let me clear these buttons so you can follow along on which ones I pushed. So we have natural log of 1/2 over 6. And this is going to be my decay rate. You can see that decay rate came out to be negative. So we're going to round to 3 decimal places. That would be negative 0.116. And even though I calculated that decay rate to be a decimal, I'm going to use the exact value of natural log of 1/2 over 6 in my calculation, because you don't want to round too early in these problems. It can cause rounding error. So now we're going to take a look at the second part of the problem. It says estimate the percentage of the original amount of that isotope released by the explosion that remains 5 days after the explosion. So we're now given a time of 5 days, and we want to estimate the percentage of the original amount. Remember, we were never given the original amount. We want to find the percentage of the original amount that remains after 5 days. So we have a model, and that model is A equals A naught, E, and the K that we just figured out, natural log of 1/2 over 6, T. We're going to substitute in that time of 5 days, and then we're going to do a calculation of this portion. That portion will be the percentage of the original amount that's remaining. So in our model, we're substituting in for T. We're substituting that value of 5. I like to write the 5 in the front because it's easier to type in the calculator. So we would have 5 natural log of 1/2 over 6 is what we're typing into the calculator. So I'm going to type E to the 5 natural log of 1/2 over 6. So that gives me, I didn't memorize that, 0.56. Okay, so we've got 0.56, which we'll round to those 2 decimal places. And I know I've got a long chain here, but on the left, I've got this A, and on the right, I have 0.56 times A naught. A equals 0.56 A naught. That's A equals 56% of A naught. So the amount that we have after 5 days is 56% of the initial amount. So the amount after 5 days is 56% of the initial amount. And that is what the question asked for. the percentage of the original amount that is remaining after 5 days. Thank you for checking out my videos. Have a great day.